Good day, seniors. This is a very short video lesson about the differentials and approximation and its use for approximations and application of the derivative. You know, the differential dy is given by y prime times dx, where y prime is the derivative and dx is the error in x. Now, if we know the numerical value of the error in y, or the differential dy, we can get the approximation, and it will be given by y plus dy. Now let's answer a problem. Using differentials, approximate square root of 27. Now we know that the function that we will deal with here is y equals square root of x, because we are approximating a square root of a number. Now, if y is equal to square root of x, it's best to have x equal to 25, because it's very close to 27, and then the error in x would be positive 2, as small as possible, so dx is equal to 2. Now if x is 25, we know that y is 5. Of course, square root of 25 is 5. Now we need to get the numerical value of the differential dy, and set up dy first. Dy is y prime times dx. So y prime is the derivative of square root of x. That would be 1 over 2 square root of x dx. Now plugging in the values, if x is 25, 1 over 2 square root of x would be 1 over 2 times 5, and then dx would be 2. So this will give you 2 over 10, or 1 over 5. So the numerical value of the differential is 1/5. Now the approximation would be y plus dy, and it's equal to 5 plus 1 over 5, which is 26 over 5. Now you can check this in your calculator how good the approximation is. 26 over 5 for the square root of 27. Now moving on, the altitude of a certain right circular cone is the same as the radius of the base, and is measured as 5 inches with a possible error of 0.02 of an inch. Find the approximate error in the volume. Now the volume of a right circular cone is 1/3 pi r squared times the altitude h. Now it's given in the problem that the altitude is the same as the radius of the base. Thus, the volume will be given by 1/3 pi r cubed. Now, the differential, or the error in volume dB, would be equal to the derivative, which is pi r squared times the error in the radius dr. All we need to do is get the numerical value of this differential dV by plugging in the given values for the radius, which is 5, and then the error in the radius, which is 0.02 of an inch. So 5 squared is 25 times pi times 0.02. That will give us 0.5 pi, and then the unit, of course, is cubic inches, the error in the volume. Now moving on, you know, this is my favorite part. The best way to learn is to do it yourself. Now approximate the cube root of 61. Use the same process I did, and you'll get this answer. Try this on your own. Oops. So that will be the answer. And then the next problem, this involves rate of change. So you get this as an approximation. Okay, good day, seniors.